Okay, so I'm going to try to have my camera like a screen shot right now, so we'll see how this works. It's kind of propped up on some books and a chair, and I'm kind of here trying to get to it. But okay, so distinguishable permutations is something we did not have time for. And distinguishable permutations mean you can tell them apart, like they're distinguishable. So like, you know, if there's 8 Cabbage Patch dolls at the store and they all have the same hair, same eyes, they're all came off the same line on the factory, I can't really tell them apart. So they're not distinguishable. But say there's, you know, different eye color, different hair color, different skin tone or whatever, then suddenly they're distinguishable. But all the ones that are made the same are not. So just because you move them around on the shelf doesn't make it look different. So if things like usually objects that are the same, like one red rose and another red rose, if you move them around, you can't really tell that you moved them around. And so this is where we need one more formula that we don't have. And this formula is n factorial, which should not surprise you because that's like, there's 8 ways, 7 ways, 6 ways, 5 ways, 4 ways, 3 ways. So that's kind of what we're used to if everybody's kind of in the picture, so to speak. But the problem is you got to get rid of the double counting. So for example, if you look at Mississippi, if I move these 2 S's around, you can't tell. Or if I move those around, or maybe one of these S's with one of those, or move the P's around or the I's around, it still looks like Mississippi. So if I want to know how many ways I can make 11 letter words out of Mississippi, and again, they don't have to make sense. Some of them are going to be duplications. So if you think about the formula that we did for combinations, when we wanted to get rid of duplications, we had that R factorial in there. And so kind of the same thing here. We're going to have R1 factorial, R2 factorial, R3 factorial, dot, dot, dot. Anything that is the same, we got to get rid of those because of the double counting. So Mississippi, I believe, has 11 letters. So 11 factorial would be the ways that I could range all the letters. 11 choices for the first, 10 for the next, 9, 8, 7, 6, 5, 4, 3, 2, 1. But I have some duplicate letters. So let's see, I's, it looks like I have 4 I's. So there'd be 4 factorial ways of moving those around. So 4 times 3 is 12, times 2, 24 ways I could move those around. I also have 4 S's, so there would be 24 ways I could move those around. And let's see what else. P's. I have 2 P's, so 2 factorial is 2 times 1. There's only 2 ways that P's can be moved around. All right, so to get the answer here, if you're going to use a calculator, you'd have to do that. So I'm going to see if you can see this. But I would go to 11, go to math on my calculator, and go to probability, and pick up the factorial key, and then divide by, and I need parentheses because I want to divide by all of that. So what is that? 4 factorial, and 2. Now again, I know 4 times 3 times 2 times 1 is 24. So for me, it might be faster to go 24 times 24. And I know 2 times 1 is 2. So sometimes I do that if I know what the factorials are. If not, I go to 11, go to math, probability, get the factorial key, divided by, and then I would do parentheses, and then I go ahead and do 4, math, probability, times 4, math, and I can go backwards to get there too. Oopsie. Shoot, math. Probability down to factorial, and then 2, but again, and I don't think you need the times in there, but we'll just put them. You know, it's just a lot of keystrokes. If you know what it is, it's faster just to type it, but if you don't know, and should get the same answer there. So we got what, 34,650 basically different words that I could make that have 11 letters if I move the order around. Again, they're nonsensical words, but they all look different. So none of them will look the same. All right, so we could do the same thing with Kansas. Like say I want to put these on little cards and move them around and create new words. So again, it's not a permutation or a combination because you have repeat digits. Like you have 4 S's and 4 I's. So when you have repetition, you can't really do that. But then you also have some double counting going on, so it needs its own formula. So 1, 2, 3, 4, 5, 6. So 6 factorial would be the ways I could arrange any of these. And then what do I have? I have 2 A's and I have 2 S's, so the double counting. So again, you could use your calculator for this. Sometimes it's faster just to write it out. 6, 5, 4, 3, 2, 1. And what? 2 times 1, 2 times 1. So 2 times 1 and 2 times 1 is what? 4. That kind of gets rid of that. So what is that? 30 times 6 is what? 180 ways. Now again, can you use the calculator? Absolutely. So I'm going to clear this and go to 6, go to math and go to probability, go down, get my factorial key, divided by, and again, if you know 2 times 1 and 2 times 1 is 4, that's a lot faster, so I might do that. And again, I get my 180 ways. Okay. All right. Let's look at the next one. So this is kind of what I was talking about. Say you have stuffed animals on your shelf at a store, and you have 6 bears that all look alike and 6 stuffed cats that look alike. And I want to know how many ways, you know, I could arrange those. So I would have 10 choices for the first thing. I mean, if I mix all my stuffed animals together, I would have 10, then 9, then 8, then 7, and so forth. So that's 10 factorial. But the problem is, if I have bear, 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 if I move all those bears around, they're the same bear. So they're going to look the same because they were produced at the same factory. They're the same everything. Same thing with the cats. Even if I go bear, cat, bear, cat, bear, cat, and then a bunch of cats, if I move some of those cats around, no one would be able to tell it. And so again, I want how many distinguishable permutations. So ones that look different from each other. So I have to divide by the duplication here. Okay. And again, I could just use my calculator. So I am going to go on my calculator. I'm going to go to 10. I don't know if you can see that. There's like, it's blurry. I don't know, hard for me to tell, sorry. I'm going to go to 10, math, go over to probability, go down to factorial, and then divide by, what do I have on the bottom? 4 factorial, 6 factorial. So 4, math, factorial, and what, 6, math, factorial, and then end of parentheses. And so there are 210 distinct ways in which I can do that, and they would actually look different. All right, that's distinguishable permutations, and then from here we're going to start working on probability.